the null.
The null.
For when computing the p-value, which hypothesis do you assume to be true? The null.
Can someone explain that one to me? I put null too, but I'm not exactly sure why I did.
So the
Yeah.
piece value is, in the video, they gave an example that the world is flat versus the world is round. So the p, obviously it says that the p value is used to use something as extreme. So you want the null hypothesis to be the true one. So the p value would be the one that's extreme as that one. Does that make sense?
Extreme as the null.
Yeah. It's
So
like, go ahead.
You assume
Oh.
the status quo to be true unless proven otherwise, right?
Yes.
So we're
And so the null is the status quo.
Yeah.
it can only be extreme if the extreme comes from the null. Because if it is extreme, then it'd be alternative.
Yeah, like you have your null, and p is just like a different theory out there trying to prove null wrong.
Yeah, from what I understand, when we're using like the probability applet and doing that stuff, we use the null hypothesis probability and we plug in a z-score for that null hypothesis, right? And if I'm trying to remember right, if it's past a certain point, then it becomes an alternative, right?
Yeah, so you set the value beforehand. That's alpha. It's your significance level. And
And
so
we
it's
just
generally
decide.
90, 95% confidence or 99% confidence. And so depending on that, you're going to get a certain type of error and things like that. And I think the default is 95. So alpha usually is 0.05 because
Okay.
alpha is the leftover of 95%. Does that make sense?
Yeah.
Yep.
And so if you calculate that and your p-value after you get your z-score and things like that is less than that predetermined alpha or 0.05, it's gonna be you're gonna reject the null.
Yeah. Okay.
Yeah, because the thing said in the reading, if p is low, reject the null.
Okay, for 5, it's the not equal to.
Yep.
Yeah.
And 6 is less than, right?
Yeah. For the first one.
And that means 7 is greater than the second one.
And then this is what we just talked about. It's the p-value being greater than alpha.
Yeah.
That would reject.
And then 9 is the opposite.
Yeah.
Less than alpha. That's funny they throw a z in there for fun. Are you guys, any questions? Are you guys ready for number 10?
Yeah, let's go on.
Yeah.
Okay, I think it's greater than, right?
Yeah, that's what I put.
And then the null hypothesis would be equal to 1500, if I'm right.
Mm-hmm.
Okay.
And this is a good assumption because it's large.
Yeah, that's what I thought. N is 40.
Are we all on the same page? Are we good?
Yeah.
Okay. And then central limit. No. Yeah, central limit.
Central limit.
1 second, my computer's being stupid. Yeah. Central limit.
Isn't it z on the test statistic?
Yeah.
Z?
I believe so.
That's what I.
Yeah, it is. I have it right here.
That was
we're
on
gonna have to do some math. Okay. What is the z-score? Okay. Oh. So.
Okay. Sales receipt at a grocery store is 150. 10 deviation 40.
Okay, so the z-score I got negative 0.9.
Hold on, I'm just finishing it.
Okay. Less than?
I got 121.5.
For the z-score?
Yeah.
Oh.
What'd you get?
Negative 0.9.
Must have done something wrong. Okay, so our mean is 144.
Yep, minus the population mean or the status
150.
quo. Yeah.
Yeah, it's 44 minus 150 over.
Did you put the parentheses in your calculator to make sure it divided the 40 by the
Square root of
Square root of n?
36.
Yeah, first?
I did.
Oh, hold on, I did this. I see what I did.
I'm still not seeing what I did wrong.
So I got negative 6 when you take 144 minus 150, right?
Yeah.
And then divided parentheses 40 divided by the square root of 36.
Wait. Okay, yeah.
So it's 144. It's negative 6 divided by 40 times the square root of 36, right?
Yep. Now I got negative 0.9.
Oh,
Yeah,
yeah. Your calculator was mad at you.
I
You
don't
need to give it more attention.
know. Sucker.
What is the p-value?
0.184 is what I got.
So do we only shade to the left?
It depends. So this one's a less than. So the alternative hypothesis is saying he thinks it's less than, right? And so if it's less than, you shade to the left. If it's greater than, you shade to the right. And if it's a two-tailed test, or you're saying it's not just in general, it's not equal to this, then you shade both the left and the right side. Does that make sense?
Yeah. So is there ever a scenario where we would shade the middle?
Not if it's a negative.
Or
Like,
I don't
does that
think
make-
so.
I think it'd have to be positive to shade in the middle. Because it goes from 0 to 100, right, on the bell curve. So I think you'd only have to shade the left if the z-score is negative. I don't know. That's how I see it, but I don't know if that
So-
makes any sense at all.
when it's set up less than, you shade to the left. When it's set up greater than, you shade to the right. When it's set up not equal to, you shade both sides.
Yes.
Yes, sir. So 0.184, right?
Yeah, that's what I got.
Yeah.
0.184, 0.05. Delta reject? Is that what it was?
So it's 0.05 and we got 0.184, so it's bigger than, so we failed to reject it, right?
Yeah.
Yeah.
We have insufficient evidence that the true population mean is less than 150. Is that it?
It's got to be insufficient. Insufficient.
Yeah, we have insufficient evidence that the true population mean is less than 150.
Okay.
I think it's the third one, right?
That's what I'm thinking. Does that sound right to you, Curtis?
Yeah. Yeah. Because we failed to reject it.
And then
Yep.
19, type 1.
There are two ways that can be made when each one involves rejecting the null hypothesis when the null hypothesis is true. Type 1.
Yeah, it has to be type 1. Whenever we reject the true null hypothesis, we say a type 1 error was committed.
For what?
I just read what's exactly in the notes. It says it says whenever we reject a true null hypothesis, we say that a type 1 error was committed.
Oh, yeah. Okay. Sorry.
And
And then
the next
20. Go ahead, Curtis. Sorry.
the next one, if it's greater than, we fail to reject it, right?
Yeah.
So then type 2 error will increase. that what you got?
That's what I'm putting, but it's because anytime you lower the probability of committing one error, you increase the probability of committing the other
Committing
error.
the other one. That makes
Yeah. So type 1 error will only occur if you reject your hypothesis and you have a number lower than your level of significance, right?
Sorry, one more time. Rachel was talking to me real quick. Sorry.
You're good. So type 1 error happens when you reject the hypothesis, and you only reject the hypothesis if your probability number is lower than your level of significance. So if you decrease the level of significance, you're more likely to commit a type 2 error.
That makes sense. The way you say it that way.
Ew.
Oh.
Okay, last one.
.05.
You just put 0.05 in the z-score?
Alpha equals type 1 error.
Yeah.
And is 1, it's equal to 1, right?
So it's saying if alpha is 0.05, compute the probability of committing a type 1 error.
So it's
So the probability of
yeah,
committing a type 1 error
0.05%.
is
Okay.
is
That makes
0.05.
I see what you're saying.
Yeah.
Oh,
I submitted. We got 100.
0.05. Okay.
So alpha and
So-
type 1 equal each other.
So level of significance 0.05, that's like shaded to the left, or what is that? I'm confused.
That's the I'm going to say I want to be 95% confident that what this answer is correct.
Okay.
Significance comes off of that, and so it's I think it's the leftovers when you divide it by 2.
Oh, gotcha. And because that stands for that 0.05 or the 5%, 5% is what it would take for a type 1 error. Now, if it had asked for a type 2 error, then you would do 95 or 0.95.
Yeah, because it's the opposite of type 1.
Yes.
Yes. Okay.
That's the best way that I explain it as.
No
All right.
clue.
Cool.
We got 100. I don't care.
Yeah, that matters. We got a good grade.
All right. Cool, guys.
All right, see you guys Tuesday, I guess.
All
Yeah, we
right.
did it.
Hey,
All right.
how did
Good night.
I'm gonna
What?
stop the broadcast